Right. Cantilevers, if you can write that name down, and we'll explain what it is. You got this, Gareth? Yeah. Cantilevers. Yeah. Okay. Got that? Okay. Cantilevers and further support. So first we have to say what a cantilever is. Now, these are cantilevers, okay? So, when you have something sticking out like this, these are called cantilevers. Now, this is a bad cantilever because it has no support. This is a better cantilever because it has what's called a strut. This piece is called a strut. And this is a good cantilever as well because it has this string here, and this is called a stay. So this one's bad. This one is a simple cantilever. This one is a braced cantilever. It has a strut. This one's also a braced cantilever. It has a stay. These two are stronger than this one. Now the definition is quite hard. So a cantilever, wait, don't write it down because we have to explain the words. So, a cantilever is a rigid structural element. Right. First word. Now I know you probably know this. Oh good, you don't. Very good, Gav. Rigid means like solid. Yeah. Structural? Yeah. Like construction, like building. Like something in a building site, construction, building. An element means like a piece. Okay? So, a cantilever is a solid construction item, like a beam or a plate. So these are called beams, pieces of wood. Anchored at one end. Okay, what's this mean, anchored? Don't know this one. Do you know this one, Khalifa? Anchored?
Yeah, I do.
What could be another word for anchored? Any of these?
Like placed?
Like placed, but stronger. So anchored means like really...
Joint?
Yeah, really joint strongly together. So like it's not moving. So anchored is like really solid connection. Okay. Anchored at one end. So it's anchored here, or anchored here. Okay. To something which is normally vertical. So usually the cantilever is horizontal and it's anchored to something vertical. Okay? From which it is protruding. What is the word protruding here? No, don't know this one. Protruding just means sticking out. Just means it's sticking out. So it's external. So an example in real life would be, if you're outside a shop and there might be a sign outside the shop. This is called a cantilever because number one, it's anchored to a vertical wall. Number two, it's outside, it's protruding. Okay, and usually number three, it either has a strut like this or a stay. Now, when I think about most shop signs,
just square.
Yeah, they're probably a lot like this. Yeah, some of them might be like this.
Some?
Maybe, I don't know, maybe, but mostly like this. Okay, so you need to write and draw this and this. It's a lot there. Okay, so I need the picture and the definition. sticking out, like external.
Oh, today it's so terrible.
Terrible?
Yeah, today it's so terrible. To me.
To you.
So the third one, there should be have a stick in here.
Here?
There's
Here?
here. The stain,
Yeah.
the third one, there
Yeah.
should have something here.
Oh no, this is just, I
No,
don't know
I
what.
mean this is the same as the second one. Just there is like inside.
No, the second one has a piece of wood here,
So
and this one has a string.
Okay, is the string there?
That's a string. That's
oh,
called a
this is
stay.
string.
Yeah, that's called a stay.
Okay.
So like, it's like this, and then there's a string from here to here.
I think there's nothing.
Ah, no. Because if there was nothing, then it'd be the
There's
same as this
like-
one, yeah.
So I'm a little confused.
Yeah, okay. Is that okay now?
Mm.
Yeah. You drew this as well?
Yeah.
Yeah. You drew it? Oh, beautiful. Wait, you didn't write these names in. Strut and stay.
Oh,
Yeah, that's important vocabulary.
okay.
I mean, you forgot reaction, so you need to learn your vocabulary.
Oh, yeah.
Yeah. And you forgot reaction. And you forgot reaction as well. I might have to give you an English test in a few days to see how many words you remember. I think it would be a good idea.
Huh?
Yeah, I think so. Because I want to see how many words you forgot.
Oh.
Maybe I'll do this next week. We'll see. Okay, continuing.
EAP test.
Yeah, a little one. 10 minutes, you know. Okay, so let me draw the picture here. A 40 centimetre by 20 metre sign is hung by a braced cantilever. The stay is 40 centimetres up the wall, and the other end is attached to the end of the cantilever. So I'll just draw this here. Okay, you have your wall here, and here's your cantilever, and it's a braced cantilever. It has a stay, which means like a string from here to here.
Okay.
Okay, right, and you also have hanging on it a sign. So I'll just put the sign like this. I think that's whatever. It's 40 centimeters from here to here,
Sign.
and 20 centimeters here to here, and it's also 2 kilograms. Okay, and I also tell you that the stay is 40 centimeters up the wall. So that means here to here, that's 40 centimeters. Now the good thing is, if this is 40 and this is 40,
Yeah, this will try.
yeah, you have this special triangle. You know this angle, 45 degrees, and that's useful to know. Okay, my first question, so here's my sign. I'll call it let's say Starbucks. Whatever, okay? Whatever the sign is. And I'll just make this a little bit thicker. Now, it's not a great picture. That goes up to the end, okay? So
Okay.
you get the idea.
Mm.
Okay. Now, let's see what we have to calculate. So, first thing here, A. What is the tension in the stay?
56.6.
Are you sure?
Oh, tension?
Yeah.
I'll get line.
Oh, the length, yeah. Yeah, the length. We might need to know the length. There's a tension here called T. That's the first force. There's another force here, the weight. That's 2G.
Yeah.
That's 19.62 newtons. But there's one other force I didn't draw on my sign. So I have the tension from the stay, I have the weight of the sign, and there's one more force. What is it?
The weight of
The walls.
Now he's got it. Yeah, what is it?
The walls reactions.
The wall's reaction. So remember we said it's anchored here. It's fixed to the wall here. So there's some force here. The question now is, how do I draw it? Do I say it's here, 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 here? Which way do I draw this reaction? So you're saying into the wall? Okay, let's see. Gal, what do you think? The same?
same as the
This way?
color. No, this way.
The other way. You're saying this way.
Positive,
Good, okay. Ben, what do you think? Left or right?
Like
This way?
no, you.
This way?
Yeah.
This way. The same as Gal.
Yeah.
Okay. And Summer?
This way.
This way?
Yeah.
Good news, you're all wrong.
What?
But that's good. So, why are you all wrong? This is why you're all wrong. So, it's anchored here. Okay, there's two things that are happening. Number one, this is not moving left. So, the wall is pushing back here. So, that was right. But, it's also not falling down. This anchor is giving it some reaction upwards. You know, if it's anchored and the sign wants to fall down, it's giving it some support up as well. So in total, the reaction is here. Well, we don't know the angle. We don't know. It might be 45, but we don't know. We don't know. So there's a reaction here, and we don't know what it is. Okay? Is that okay? Is it okay?
Yeah.
Okay. So let's continue. So I think it would be useful if we take this T and resolve it. Okay? So you can change it into, let me put it in black here, this way and this way. So how much is this one here? These are both the same because they're 45 degrees. How big are each of them? They're both T over root 2. Cos 45 and sine 45, they're both the same, 1 over root 2. Yeah? Is that okay? Okay. Now, let's see. Let's see what equations we can make. So, this or here, what I'll do is, we don't know the angle, so what I'll do is I'll call this or x and or y. Because I don't know the angle. Or if you want, you can say or cos theta, sine theta. We don't know the angle. Okay. So you can say or y plus t over root 2. That should equal 19.62. Yeah? You could also say or x. What should that equal? Or x is going to the right.
T over.
Yeah.
Equal to
Root
2.
2. Root 2. Yeah?
Okay.
And the last equation is the turning one. Where should we place the pivot? Well, I think a very good place for the pivot is here. Because we don't know anything about or. But if I put the pivot here, then what happens? The or is gone. We don't consider it. Is this clockwise or anti-clockwise? This one here, 19.62. Clockwise, yeah. This is clockwise. Now what about this guy, t over root 2? Anti-clockwise. Yeah, you're right, anti-clockwise. And what about this guy here? This t over root 2 here. This one here.
Clockwise.
You think clockwise? Okay. Anyone else? Other ideas? Or we agree it's clockwise?
Just force to the wall.
This one's confusing you?
Yeah,
Does it make it turn clockwise or anti-clockwise? You said this one's anti-clockwise. This one here? Clockwise.
Okay.
So what would this one do?
Which one?
This one on the ground. Nothing. Why does this force do nothing?
That is all of these.
Not that. Something else.
Just give a force to the wall.
Yeah, but okay. It doesn't do anything
Yeah.
because the force goes through the pivot.
Oh,
You see, let me show you here. The door. Oops. Is it still on? Good. Look, if I pull this at an angle, I can turn it.
Yeah.
But if I push a force this way here, if I push so that my force goes through the pivot, I cannot make it turn.
Yeah.
So there's no turning effect here. Okay, but the force going this way, perpendicular, that will make it turn. So in my picture here, this T has two parts. We only care about this one because it'll make the cantilever turn anti-clockwise. And we care about this one because it makes the cantilever turn clockwise. We don't care about this one because, like with my door, it doesn't make it turn clockwise or anti-clockwise. And we don't care about this one because if I put a force here, I cannot make the door turn. I have to be at least here. Okay? So let's see. Let's make the last equation. This distance here is 0.2 multiplied by 19.62. That should equal what?
0.4.
Yeah,
Multiplied t root 2.
t over root 2. Okay, write that equation down.
Draw first.
And draw 2, yeah.
Stop.
Ben, could you calculate the t when you're ready?
Oh.
0.14.
That seems too
No,
small.
no, it's 14. 14.
40?
Yeah, 14.
14
Yeah,
newtons.
yeah.
Okay. I trust you.
You trust me? I don't trust myself. Yeah, I trust myself.
Good, good, good. Will I continue with B part B? Yeah? So, look, part B now. We've done part A. Part B. What's the tension? We got part A. Okay, now on to part B. How much horizontal reaction is there? That means Rx. Now, what can give us Rx? Look, you have the T, so now you can easily get Rx. Okay, so maybe Gao, you can calculate that for part B, and Ben too.
9.89.
9.899 newtons. Okay. C, what's the vertical reaction? So that's Ry. So I think this equation can give you Ry, because you know T now. Yeah, so what's or y? Nine point.
7 to 1.
What you got?
Nice.
Okay.
It's either.
Close enough. It's fine. It's fine.
It's fine.
Close. It's close. Okay. What is the magnitude of the reaction? So part D is I want to know what is the magnitude. So that means I want to know or. So how can I calculate or?
Yeah.
How do I get or?
I don't have one.
You have or x and you have or y. So how can I get or?
God, it's too early.
It's too late.
Uh,
Square root.
so root
Or
of
x squared plus or y squared. Yeah.
Huh?
Yeah.
It's not
13
Okay.
13.87
587.
newtons. And finally, E, how can I get this angle? This angle.
Call this
Yeah, theta, how do I get this? Ben, how do I get it?
13.87 call
No. Tan
tan
inverse
inverse.
or y over or x.
So what is RY?
Or y over or x.
So it's
Just
so it's tan Rx root divided Ry.
Tan inverse.
But
Or
you can
y.
just say
Oh yeah, so you could say
tan Rx.
tan theta equals or y over or x.
Yeah.
14.4.
Rx over 1 Ry.
Or y over or x.
Why?
Why?
Because it's
There's or x,
yeah.
there's or y, which is the same as this, and there's theta. So opposite over adjacent for tan. Yeah. So-
14.4.5.
Yeah. No. Tan. Helper, Ben.
Those who can handle. Okay, so
Yeah. Here, look.
it's fine.
That's what you typed in. Tan inverse.
Did it?
No.
Yeah.
Shift.
Yeah. Press shift first. Tan.
I don't know how to use that.
Yeah.
Okay. Okay. Cool.
Got
Good
it?
stuff.
New stuff today. New stuff today. Oh my goodness. Okay. Mm. Yeah, that sounds about right. About 45.
It's
Mm.
we want to change one. I lose to euro. we want to change one. Yeah,
I tell you which questions I want you to do for tomorrow, and then you can finish them on.
No.
Hang on, let me think. Wednesday. Yeah.
Wednesday. Tomorrow
No,
we
this-
have class.
Yeah, I know. No, listen,
So-
listen. For Tuesday, for tomorrow, go to page 33. 33. 33. So for Tuesday, I want you to do 3, 4, 5. Now you should have 3 finished.
Yeah.
So then it's just 4 and 5. Okay? And then also on page 35, 1 and 3.
Until tomorrow?
For Tuesday. And for Wednesday, I want you to do the other question. So that's 1, 2, and 2
Oh,
for Wednesday.
okay.
You understand?
Okay.
Yeah.
Tomorrow
So
is
That's more easier? Or
No,
more
no,
work?
I'm just splitting in
Okay.
half the work.
Mhm.
So do half tonight and half tomorrow.
Mm.
You understand?
yeah.
Now you should get question 1 done, and then you can go home. It should take you about 10 minutes to do question 1.
Now?
10 minutes?
Well, less. It could take you less, but you seem very sleepy today. So
And Wednesday, which question are we going to read?
for tomorrow,
So Wednesday.
for Wednesday,
Just select.
on page 33,
Uh-huh.
question 1 and 2,
Okay.
and then on 35,
So now,
question 2.
now we do the question one.
So now you might as well do question 1 on page 35,
Okay.
and then you only have 1, 2, 3 for homework.
Okay.
Yeah, seems fair.
Oh no. I'm fine.
Questions for this.
What?
No, I just like language.
Look, a braced cantilever steel beam is supported by a 26 centimetre stay.
So the string
This is string is 26
Yeah.
centimetres.
Oh.
The stay is 10 centimetres above the hinge.
That's 10.
So that's 10. Very good. Okay.
This.
And the beam is length 24.
But that's cantilever.
The cantilever is 24. You see? Okay, Gail gets it. You can ask her.
Oh. What is T?
That's not T.
Which is
That's T.
that's
That's T. And my question is, what is T? Yeah. That's like the example I just did there.
this is a T.
Yeah, that's T.
Yeah.
My question,
Yeah.
how big is T?
Oh, I think maybe easier.
Easy? So we don't have angle. And the
No problem.
But we have
We don't need angle.
You told me the angle?
I don't know, I think you need the angle.
We need angle.
Well, it's good
But
to know.
we have this.
You have the lengths, yeah, so it's enough.
We need angle.
Sine is this to this.
Oh,
Oh, this over the
Yes,
sine.
yes.
I noticed. What's your name?
Hmm?
Your name, please. I didn't get your name.
Oh, Stephen, sorry, that's rather important to know.
And how do I get access to this?
Yeah, one of the students will send you the link, I'm sure. It's on YouTube.
Okay.
So I have a channel on YouTube, so you can get it there. I don't see, where can I'll type it here on the screen for you. Boom, boom, boom. Where the heck is Notepad? Where's Notepad? Maybe this will do. Ew. No, thank you. I'm trying to find my Notepad program there so I can actually type a bit of just plain text. Feather pad, maybe. Yeah, there we go. Okay, so what's it called? YouTube.com/c/mathsgorindsie. That's the channel. You can I zoom in? I don't know if that's any clearer for you to see. don't know how to make this bigger. Can you read that okay?
Yeah, it's okay.
Are you sure? Can I close this?
Yeah.
Oh, and again, did you get the email address at the start of the class? If you need to email me. I'll bring the book to class tomorrow.
Okay.
Maybe you could just take a picture on your phone for tonight.